Hi, and welcome to Geeks for Geeks. Today we would be doing the Geeks for Geeks 102 post contest analysis. For those who don't know me, I am Siddharth Hazra. Currently, I'm an SD at Geeks for Geeks, and I would be the mentor for today's stream. So, okay, and the time goes on and on. Okay, Dheeraj, fair enough, I came. Okay, hi Madbar, hi Astha Jain, hi Gaurav Thakur. Okay, so let's talk about the insights I had after solving this problem. So when I solved up this contest, it seemed to me a fairly balanced contest. We started off with a problem that is strong students in a school, and if you write it down in a pen and paper, it would be very easy to understand that to maximize the difference and the same person. The note that is there that one student can be a part of more than one group makes it a easy problem. Then we move forward to the next problem. The next problem is easy to understand and it gives us a hint that yes, something related to ordering is needed at this point of time. The last problem is of a very variation of a very talked about shortest path algorithm topic where I was expecting it to be a multi-source weighted, like multi-source Dijkstra is a very underdog algorithm, but still I think that it is one of the most vital algorithm. Like it can be used in the same manner as BFS. Like if we just insert all the sources before doing the BFS, we can just do a multi-source BFS. In the same manner, we can just insert all the things in the priority queue before we have the whole Dijkstra, and it can be converted to a multi-source Dijkstra, and we can solve it. So I was expecting this, but this was a single source shortest path with a weighted graph. Okay, so my first question के size में problem क्यों दे रहा था? I don't think. Okay, fair enough. Yeah, everything looks fine. I would just present the screen itself. So window, yep. I think this one would be good to go. Yep, this is good enough. Now, let's talk about the insights of this problem. Okay, the problem tells us that, let's go back to the problem statement. The problem tells us that we are given an array. Okay, that array can be 1, 2, 3, 4, and 5. Let's say this is the given array. Okay, and then we are also told that we would have something known as m. Okay, so just a sec, let me just have it. So I need to close it down. Yep, and this is good to go. Just let me connect my tower. Okay, so quickly see this problem. Okay, not visible. Let me just see if the internet is down or not. So quickly just read the problem quickly. Strong students in a school, yep. The most important step of this is the constraint itself. Okay, so quickly just read the problem and get acquainted with it. Mhm. So when you're done reading the problem, it would just take a minute or so. Mhm. Yep. So I think you are done reading about this problem. Now we can move back. Can you elaborate, Shubham Gond? Okay. I think we are good to go now. Okay. So now I have already written some part of the question. So now in this question, we are given that we have m students and this is the array. Okay, this is, let's say, student 1, this is, let's say, student 2, this is, let's say, student 3, this is, let's say, student 4, and this is, let's say, student 5. Okay, this is given. Now we are told that we need to take groups of 4. Okay, make groups of m. This is told to you. Okay, now let's say what I can do is, and one student can be formed in two groups. Okay, make groups of m, and this needs to be 2. Okay, now what you can do is, you can take the first 4 people in group 1 and the next 4 people in group 2. Let's say this, and this can go in group 2 itself. Okay, let's take a very contradictory color. Yep. So this can be made to group 2 itself. Okay. So now, if group 1 is what? 1 plus 2 plus 3 plus 4. And group 2 is what? 2 plus 3 plus 4 plus 5 itself. The sum is 3 plus 3 is 6. 6 plus 4, that is 10. And here the sum would be 2 plus 3, that is 5. 5 plus 4, that is 9. 9 plus 5 is equals to 14. That is why the absolute difference between it, is 4. That is how the output 4 is popping up. Okay, is my screen visible? Okay, now let's see the second scenario. Let's go to the next page. Yep. Okay, now see, the values are nothing but 5, 8, 11, 40, and 15. Okay, and we are told to form two groups, and here the value of m is what? The value of m is 2. So form two groups of 2 people each. Okay, so what I can think of is, I would make the first group of this, that is 5 plus 8, and I can make the second group as 15 plus 40. So 5 plus 8 is equals to 13, and this would be 55. So 55 minus 13 is equals to 42. So that is the absolute difference, and you need to maximize this absolute difference. Now, there are 2 3 things that needs to be told. The very first thing is, some elements can be skipped. Like it might be a scenario that some elements don't belong to any group. Okay. The very next most important constraint is that one element can exist in more than one group. Okay, this is the scenario. So now this is, let's say, group 1, this is the sum of group 1, and this is the sum of group 2, and I want to maximize the absolute difference between them. Okay, see, if I want to maximize the absolute difference between them, yeah, so if I want to maximize the absolute difference between them, then I should have the group 1 as maximum as possible, and this should be as minimum as possible. Okay, to make group 1 as maximum as possible, I need to insert maximum m elements from the array, and to minimize the group 2, I need to insert minimum m elements. Okay, like this is just like this scenario, that if I want the absolute difference between, let's say let's say the idea of this would be that, let's say this is me and this is my girlfriend. Okay, I'm a very tall person. To be honest, I'm not a tall person, and I want the height difference between me and my partner to be as maximum as possible. So I would try to find a partner who is as short as possible to maximize this gap. So in the same manner, I can say that to maximize the gap between group 1 and group 2, I would take maximum m elements and minimum m elements. Okay, so now the idea is very simple. What we can do is, we can simply Mhm. we can simply sort the array. Sort the array. Okay, so let's say how it would be. Like earlier, the value of the array given is 5, 8, 11, 40, 50. After sorting, this one would become 5, 8, 11, 15, and 40. So the maximum two elements exist from here, and the minimum two elements exist from here. Okay, so I would take the first m elements, okay, in group 2, and the last m elements in group 1, and then I would just simply return group 1 minus group 2. Okay, do I make sense to everyone? Give me a quick yes or no. So now let's code this up. So am I clear with this thing? Give me a quick yes or no. I'm waiting for the next 1 minute, and then I would just simply move forward. Okay, fair enough. Thank you so much. Now I would just simply share this up. Okay, thank you. So now let's just have this. Is my screen visible? Yes, it is visible. I can make it large, and then I'm a very lazy person, so would be having A at this point of time. Now I would simply sort the array A comma A plus n itself. After this point of time, I would say int minimum is equals to 0. Okay, and then I would take the first n elements in the minimum. Okay, so for int I is equals to 0, I is less than m and I plus plus, and then I would say min plus equals to a of I. After this is done, the last m elements would be maximum. So I would just write max is equals to 0, and this time we would start from the back. So for int I is equals to n minus 1, I is greater than equal to 0, and I minus minus. Okay, and this time would be max plus equals to a of I. But I should be greater than what? N minus m elements. Okay, so that we just take the m elements. Earlier it was taking the whole array, so we are taking n minus m elements only. Okay, till the value of n minus m elements. Now we would return maximum minus minimum, and this would be the largest possible value. Yep, this is done. Now tell me, is this code clear to you or not? Give me a quick 0 or 1. Yep, this is also correct, as Gaurav Thakur told. This is also correct. By the way, how much possibility to not take 11? Just take the first m elements and the last element. We don't need any possibility, to be honest. Now, thanks a lot, Gaurav Thakur, for your maturity. That when I started discussing the solution, then you shared the solution. It gives people immense knowledge to see others' solution also. I don't ever claim that mine is the best solution. So you give a proper dimension to everyone. But thanks a lot for this maturity that when I was explaining the concept, you didn't give the solution. Thank you so much. I respect it a lot. Okay. Thanks a lot, Prankhur Garg. Thanks a lot, Sajal Kumar Singh. Now let's move forward to the next problem. Now let us move to the fourth page. Yep. Mhm. Okay, it's getting updated. Yep. Now, this question is a good question. Okay, so now you are told that you are given a binary tree. Okay, let us first understand what is binary tree. A binary tree is tree. Okay, tree with at max two children. Okay, tree with max two child. Okay, two children. Okay, this is what is given at this point of time. Okay, now you are told that you would be given a node. Okay, so let us first understand this. Let us understand some concepts of trees. Okay, so let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Okay, now let's say the node that we are considering at this point is 4. Okay, then 5 is 4's brother or sister. Okay, like say let's just evaluate it with the real life scenario. My sister, whose parent is same as my parent. Okay, let's say this is me and this is my sister. Okay, I have an elder sister also, and this is my parent. Okay, so we both are brothers and sisters. But let's say my mother's brother. Okay, let's understand this. let's say my mother's brother, I would just write MB. My mother's brother's family's child, okay, mama ka ladka, okay, mama ka ladka would be our sibling, okay, or cousins, okay, okay, cousins, okay. So in the same manner, for the node 4, the node 6 and the node 7 are cousin. Why? They both don't have the same parent. Okay, this is wrong. Yeah, cousin. Okay, and this is known as the root of the binary tree. This is these node all nodes are referred to as the leaf of the binary tree, and this is the direct parent is known as parent of the binary tree. Okay, all the other parents which are not directly related are known as ancestor of the ancestor of a particular node. These are all terminologies that you need to understand before you move forward to solve up this problem. Okay, so I hope you are now acquainted with the terminologies that are needed for this problem. Let's go to the slide 5 and let's understand it a bit more. Okay, now you are told that we are given a tree, okay, 11, 3, 10, okay, this is 1, this is 8, this is 4, and this is 7, and this is 5 itself. Okay, the left child is known as the left child, the right hand side child, like this would be referred as the left child, and that side would be referred to as the right child. Okay, do I make sense? Fair enough. I make, okay, fair enough. Now we move forward to this thing. Now we are told that here the node that is to be considered is 1, and we need to find all the cousin values. Okay, like this is not to be considered, this is not to be considered, and all the other nodes are to be considered in this. Okay, in this. Okay, fair enough. Do am I able to, like, are you able to see the screen? How is the short function working? Okay, just a second, let me just give you this. So this is sort C++ STL. Yep, this is how the sort function is working. Okay, does everyone who is eligible for the GFG Weekly Coding Contest receive the awards? Yes, absolutely. Priyanka, I have given the article link explicitly for you, so I deserve a chocolate from you. Okay, fair enough. Now we move forward. Okay, now we are told, most welcome. Okay, so now we are told that all the siblings are, we need to understand this. Okay, this is what is told. That is why the output to the very first one is just 4. Why? Because 8 is the direct parent of it. Let's take the second example. Okay, let's just slide a little bit. Yep. Now we are told that at this point we are given 8, and then the child is 4, then this child is 6, this child is 2, this child is 7, and this child is 5. Okay, 2, 7, 5. And then this would be 1, 9, and this would be 1, and this would be the 10 itself. Now we are told that k is equals to 4. Okay, so I can't be a cousin of mine, so this is not possible. My brother can't be a cousin of mine, this is also not possible. Are there any other nodes which are left at the same level? No, it is not. That is why the output to that value is -1, because no cousins does exist. Okay, fair enough. Now let's talk about the idea that needs to be understood. Okay, so now this is, let's say, a node. Okay, let's say this is a particular tree. This is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, this is 11, this is 12, 13, 14, and 15. Now, let's say you ask me that the node to be considered is 4. Okay, the node to be considered is 4 here. Okay, then I need the summation of this value, but not this value, not this value. Okay, so I can say that first we need like sum of all the values on that particular level. Okay, so sum of all values at nodes level, whatever the node we are given, nodes level, and then we need to subtract the value of node and its brother or sister. Okay, so if we take, just let's see this diagram. If we take a 4 plus 5 plus 6 plus 7, let's take the example also. This is the example. So let's just take 4 plus 5 plus 6 plus 7. Okay, then we subtract the value of node, that is 4, and the brother and sister, which is 5. Then we would have the value of 6 plus 7, and yes, that is the value to us. Okay, fair enough. This is how we can solve this problem. So now remember this thing. So sum of all the values at node level. So the very first thing that you need to do is, the algorithm would be find the level of node, find the level of the particular node itself. First we need to find the level of the node, then we need to add everything, and then we need to subtract the value of node and the brother or sister. This is the most vital step, so you need to remember it. So this is how the algorithm would be. Okay, so am I clear with this algorithm? Give me a quick one. Now let's discuss it a little bit more. So now find the level of the node. This can be done by simply doing a level order traversal or a BFS, not DFS, sorry. So this can be done by level order traversal, level order, or BFS, that is breadth first search. Adding up everything is easy. Again do the same BFS and add everything, and then you need to save the value of brother or sister, and then you need to subtract it. Okay, now the question is, how can we find the level using BFS? So am I clear with this approach? First tell me this. Am I clear with this approach? Give me a quick 0 or 1. What if the node 10 had another child? Would it be what would be the answer? So if 10th node 10 has another child, let us just see node 10 has another child. Where was node 10? Yep. So if node 10 had another child, that value would get added. Suppose node 10 has another child known as 3. So that value would get added. Okay. Rohan, am I clear to you? I deserve a chocolate from you also. Okay. So now let's discuss this. Now the question is, how can we really find up the level? So let's say this is 1, this is 2, this is 3, this is 4, and this is 5, this is 6, and this is 7. So what we can do is, we can say that 1 has a level of 0. So 1 has a level of 0. Then the left child of 1 would have the parents level plus 1. Like what I'm like, suppose let's say I am fifth generation. I'm fifth generation of my whole heritage. Okay, like family. I'm fifth generation of my family. So my father would be fourth generation. So if for two's parent is zeroth generation, then two would be the first generation and three would also be the first generation. And 4 would be two's generation plus 1, that is 1 plus 1, that is 2. 5 would be two's generation plus 1, that is 1 plus 1, that is 2. And same here for this. This is how we would say that the level of root is 0, and then as we proceed forward, we would just pass on level plus 1, and then we would eventually have the level at each step. Okay, this is how we can solve up this problem. Okay, now let us move to the coding part and it would make more sense. Any more further queries? जल्दी जल्दी बताओ भैया, जल्दी जल्दी बता रहा हूँ. It's 9:06 and I'm implementing the second solution at this point. सुबह पनवेल निकलना है. Okay, fair enough. Now what I can do is, I would like, BFS thing is easy to run, but what I would do is, I would save each node's level in a vector. Okay, vector of pairs. Okay, I found this solution by someone and I really liked the idea, so I am implementing it. Okay, so pair of int, and this one would be int, and I'm extremely sorry I don't remember the name, but kudos to you. This is a very simpler solution than me. Okay, first I would save the levels. Okay, so I would start from the root node, node star root, and this would be the node that needs to be considered, and this is its parent. Okay, and this is the depth or the level. Okay, okay, first we would push back. Okay, how we would push back here, just see it with absolute care. This is the node. Okay, so every time a node would have its parent also. Why we are saving the parent? To know, like suppose the my name is Siddharth and my sister's name is Shreya Hazra. So my parents' name is Subrata Hazra, okay, and my sister's father's name is also Subrata Hazra. So by taking hold of the parent name, I can say that yes, we both are brothers and sisters. But if I ask my cousin that who is your father, then his father name won't be Subrata Hazra. So that is why the knowledge of what is his parent is very important at this point. And root's parent would be -1. Okay. So the depth and the parent, they both are very important. Okay. So we would save the level and the parent. Okay. Now I would say if the left child is present, then we would visit the left child. Okay. That is rec of root dash left, and everything else would be the same thing. Root dash left. Okay. And node would be left's data. Okay, root dash left dash data, and then the parent would be the current root. Okay, suppose I started from my father and then I have me. So for me, the parent would be my father. So in the same manner, from root we started off, and then we are moving to the left child. So for the left child, the parent would be the root. Okay, that is why for this the parent would be the root. And as we progress downwards, the level would increase. So whatever the level was of the parent, we would just add +1 to it. Okay, and then in the same manner we would check if the right child is present or not. Okay, and we would write right here, and we would write right here, right here, and everything else remains the same. Okay, and then we are done. Okay, we would go till the point we hit the leaf node. Why hit the leaf node? For the leaf node, the left as well as right won't be present, and this function would get completed. So by doing this, we are saving the level of each node and the parent of each node. Do I make sense? Give me a quick 0 or 1. So while using BFS to have them, if the parents are not the same, then they were the cousin. Yes, absolutely. Repeat once more. So what we did was we started off from the root. Then as we progressed further, like suppose this is the root, we progress downwards. So for this node, this one would be the parent. The level would be +1. Okay, and that is how we are saving the level and the parent of both of them. Okay, now we are moving forward. Now that we have the information of every node, then we would simply call the first one, that is rec of. We would start from the root and then we would pass the root's data. Okay, and initially the level is 0 as well as 0 itself. Okay, then we would say the parent is -1. We would initialize first, we don't have any parent, and the depth is also -1 at this point of time. Then we would just iterate over this vector v. Okay, auto e auto it dash iterator dash v. So first we would have the node. So this is the node. So int node is equals to it dot first. This is the node. Okay. Then we have the parent, which is it dot second dot first. So we have the parent, which is it dot second dot first. Then we have the depth. Okay, that is the level. The level would be nothing but it dot second dot second. Okay, now we would check that if this is the node, this is the node that we are trying to consider. Okay, if this is the node, then we would first save the value. If it dot first, if the current node is equals to the value of key, then we would save this value. Then we would say parent is p, and the level of and the depth of u is 11. So we would first find the. So what we did, already told you that find the level of the node, as well as we are first finding the level of the node as well as finding the parent of the node at this point of time. Then let's copy the same thing again. This time we would have another if statement, and then we would say that if the parent is not equal to the parent we are trying to consider, like my cousin My parent and my cousin's parent should not be same. This is the very first condition. If P is not equal to the parent, as well as the level should be the same. So we would say that the depth is equals to the level. If this is the scenario, like if the parents are not same and they are at the same level, then it would get added to the answer. Answer plus equals to a particular node value. Okay, and then we would return the answer. Okay, so we would initialize answer is equals to 0. Okay, in the end also, if we are not able to find anything, if answer is still 0, then we would make answer is equals to -1. Okay, simple enough. Like here it is told that if no cousins are present, return as -1. That is why I'm doing that. Now let us just compile run and see how many errors are we making. Okay, okay. So we don't make any errors, and as this is a long solution, so I would consider sending the solution in the chat itself, but making an IDE link. So quickly tell me if this idea is clear or not. I would be waiting for the next 1 minute, and then you can simply tell me that if this thing is clear or not. And then we would move forward to the next one. I have awesome explanation. Thanks a lot, Sony Bravia TV. You have a very different name. Okay. So I have one request, sir. Can you please tell the dev team to remove the hint feature because people are making alternative accounts to see the hint and making the submission on the main account. So even though they remove the hint thing, still it might be a scenario that they might directly see the solution. Let's say the solution as well as the hint both are removed. Then also people might submit solution and get an wrong answer, and then they can avoid, and then when they get an AC, then they would submit that solution from their original account. People can do it. Okay, so to be honest, as of now, I didn't came across a process like I have seen a lot of online judges. I belong from the dev team because I'm a software engineer at Geeks4Geeks. So I have a better understanding of how these online judges work. So there is no alternative where we can stop people from cheating. If they are willing to do it, they would do it. Like, even though everything is stated at this point, then let's say I'm good at problem solving and I don't want others to improve in that. I can directly start streaming over YouTube and I can solve the problems in real time while the contest is going up. So if the people are not true to themselves, then there is no way we can remove it, to be honest, because I too belong from the dev team, as well as like at this point of time I am at the other side of the screen. But when I started off, I was on your side, where I was also thinking that how people can stop. Okay, so just try to just give your part. Okay, don't think about others, try to give your part, try to be your best version. Okay, I can move forward to the next one. Time answer space complexity. The uh, so we are making a DFS. So the DFS thing, BFS or DFS, anything you say, the time complexity is big O of n, and the space complexity is big of n, because we are saving everything in the vector. But if we don't use the vector, we can skip up this thing, and you can use. Thank you for the responding, sir. You are my inspiration for looking at things from positive side. It's not true, brother. Actually, if you stop ranting and you see the beautiful things and you move forward, it would, like, it becomes easy, to be honest. Because you can't real, like, when I started off, like, when, so I have been rejected on Geeks for Geeks only 2 times. Okay, so third time I was invited to Geeks for Geeks for internship, but 2 times I have been rejected over Geeks for Geeks also. So many a times I used to think that this is not unfair or something, but eventually things would fall into place if you are true to yourself. Like, there is someone maintaining a diary that you are being true to yourself or not. Okay, so now we can move forward to this thing. Yep. So before we move forward, let me just give you a disclaimer kind of thing. The disclaimer is, okay, I need to share my screen. Mhm. Okay. Now see, before I move forward, there is a small bit of disclaimer for you. The disclaimer is that the knowledge of Dijkstra is needed. If you don't know what is Dijkstra, Dijkstra is of single source shortest path algorithm. Okay, it is a single source shortest path algorithm, and it is a topic of graphs. Okay, so if you are not acquainted with this, just you can see up the video, you can ask the doubts in between, but you need to have the understanding of graph, then you need to have the understanding of single source shortest path, and then Dijkstra. Because if this question was of direct Dijkstra, then I would, okay, then I would have explained it, but this is the level 2 of Dijkstra. That is why explaining Dijkstra and then explaining this question would be a very hectic process, and the stream would be absolutely very boring and people would leave eventually. Okay, so what is the number of likes counter at this point of time? Let me just say it. GFG practice. The like counter is absolutely very less. It is just 13 likes at this point of time. Can you please increase the like counter? Okay, because it seems like it doesn't seems good. Okay, fair enough. Now we are told that we have a source and a destination. Source and a destination. So, as the name suggests, we need to start off from the source and we need to finish off at destination. Okay. Now there are two modes to travel. The very first mode is the railway, okay, which is generally the cheaper one. And next one is the airway, which is generally the costlier one and more time efficient. Okay, but we won't be going in that direction. So now you are told that at each source and destination, we would be provided with both railways as well as airways. Same goes for distance destinations also, railway as well as airway. Now, this is very that like this needs to be understood that you can start from railway and you can end up with railway. You can start off with railway and you can end up in an airway at the destination. Like you can end up at the airport of the destination. In the same manner, you can start off with airway and end up at railway, and the same manner airway to airway. Okay. Now every city has railway as well as airway. Okay, and each railway as and each airway has a cost associated with it. Okay, like suppose this is station number 1 of railway and this is station number 2 of railway. Let's say this is Kolkata and this is my hometown Dhanbad, okay, which is in Jharkhand. Okay, let's say that I take up from Kolkata to Dhanbad and we have a cost associated with it. Now Kolkata also has a airport. Let's say this is terminal 3. Okay, this is terminal 3. Let me just make it a bit clear. This is terminal 3 of Kolkata. Okay, now this is station of Kolkata. This is terminal 3 of Kolkata. So now to travel from a particular city's station to the airway, we have a cost as X. Okay, the cost associated to that is X. So this cost would be given, and this cost for every city is fixed. Please remember this. Okay, now this question says every cities will have both railway and airway. I didn't read the question so properly. Just let me see. There are M1 tuples. There are N cities. Okay. No, it is not told that every city would have the same number. M can be M comma N can be, yes. The number of railways and airways can be less than N. Okay, it is not necessary that every city would have railway as well as the airway. Okay, it is not told. Jashwant, this is a query answer to Jashwant. This is not told. Okay, thanks a lot, Jashwant, for clearing up this. Okay, fair enough. So now you need what we like. The question tells us that we don't care that if you use a railway or a airway. Like let's say this person is like me who doesn't considers time. Okay, he considers money more important. Okay, but to be honest, I consider time more important. But let's say I consider money more important, like I am low on budget, so I need to have the cheapest way. Okay, I don't care about time. Okay, time is not a constraint here. Okay, I don't care about how much time is to be taken. I want the cheapest way to travel from source to the destination. And as I already told, I can start off with railway and end up in an airway and vice versa. Okay, so we'd only care about the cost at this point of time. So what can be the way to solve of this problem? Okay, now let's solve the very first example that we have. Okay, so here we are told that source is equals to 0 and destination is equals to 1. Am I visible? Yep. Okay, now we are told that what we are told, airline which takes couples, we are given the right flight from I1 to I1, which that lesson airline I0 to I1, which takes time, airline I2. Okay. Okay, minimum time taken, not the minimum cost. Okay. Sorry about that. I would just, yep. So this person is the true me. He is the minimum time taken. Sorry. Minimum time. Okay. So now we are told that, like, let's start. Mhm. Minimum time. Okay. So now we are told that we have an airway from 0 till 1, and the cost of that airway is 10 hours. Okay. We also have a railway. Let's say I would draw the railways. So we have a cost of railway 1 to 0, and the cost of that is 8. And then we have 0 to 1, and the cost of that is 7. Okay. Source is equals to 0, destination is equals to 1. Okay. 1 to 0, 0 to 1, 0 to 1. Okay. And the cost of this is 7. Yep. So here we are taking a time frame of 10 hours, and railway is taking less time, 7 hours. So which is more time efficient? This is more time efficient. So the answer to this is 7 itself. Okay. So now let's move to the next example. Here we are told that again green would be for airlines. So here we are told that we can move from 0 till the value of 1 by investing a time frame of 10 hours. Okay. Then again we can move by railway by investing a time frame of 7 hours. But here source is equal to 1 and destination is equals to 0. So we want to move from 1 to 0, but there is neither a flight nor a train which can help us to move from 1 to 0. That is why the resultant value to this is -1, that this is not possible. Okay. So am I clear with the sample test case? Give me a quick one in the chat and then we would move to forward to the explanation. So now the idea is very simple. Okay. So see, we can clearly see that we have two graphs basically, two weighted graphs. Okay. Let's say this is 1, this is 2, this is let's say 3, and there are weights associated. Let's say the weight is 1 and 2. This is the first graph. Let's say this is for, let's say, airways. Okay, this is for airways. Now let's draw for railways. Now let's say we have the same kind of graph 1 to 2, 2 to 3. Okay, and the cost is let's say 2 and 3. Okay, and this is for railway. Okay, now let's say if I just have the airway graph, let's say if I just remove the railway graph, I just need to tell you at what is the shortest time to move from city 1 to city this. Okay. Suppose we are given source. Suppose we are given the source and a destination and we need to only use airlines. Then this is very easy. Why? Because we have a weighted graph. We have a source and we have a destination. So the answer would be nothing but using Dijkstra. Okay, weighted graph. But here we are told that we need to consider the cost efficient option or the time efficient option. So we can select either of that. So how can we do it? Okay, this two graph thing is making a problem. So what we can do is, we know that from here to here, if we want to go, the cost is X rupees. So we would simply have a cost of X rupees to every node. We can simply have this kind of thing, and then we can simply solve up this problem. And then this graph would be one graph, and then moving from one station to another station, X would be catered. So this can be catered. That is why a very so what we need to do is, so the idea is very simple. The understanding was like a bit different. The idea is very simple to use Dijkstra, but to combine the graph. So what can be the combining factor? Bring Draw a edge in between and have the weight of x in between. Have the weight as x. There are two graphs. Okay. So if there is one graph, it is very simple. Just use Dijkstra. Two graph is making a problem. So we need to combine the graph. How to combine the graph? What can be the combining factor? We just draw an edge from the railway station to a airport, and the weight of that would be x because it would require x unit of time. So just the building of the graph is a catch here, nothing else. Now we would move forward to the explanation and it would make more sense. So as I told you that this is level 2 of Dijkstra. So Dijkstra is already implemented here. I would be just doing the logic part, okay, which is the minimum part. So now let's make everything as lowercase. Mhm. And railway as just RL and airway as AR. Okay, so we need to write absolutely very less. After this thing, this would be done. So we would have a vector, okay, vector of pair of int comma int, okay. Mhm. And we would have adjacency list we would just use, and the size would be 2 multiplied by n, okay, just to be on the safer side, okay. Now we would first insert all the railway lines in the graph. So for int I is equals to 0, I is less than m1, there are m1 airlines, yep, m1 airlines, and I plus plus, and then we would say adj of adj of airline I comma 0 dot push back, okay, airline of I comma 1, okay, comma airline of I comma 2. So basically this thing is from U to V with a cost of AIR I comma 2. This is the explanation of this thing. Okay. Now we would do the same thing for the railways. And this one would be RL, this one would be RL, and this one would be RL, and this one would be RL again. So now we have the railways and the airways in the same graph. But as we can see, the nodes would collide between them. Okay, like the single, like we won't be able to differentiate that if this particular edge is of railway or airway. So the little bit of catch that we can do is that we can add plus n to it. Okay, we can just add plus n to both. Now we would be able to differentiate in the same graph that this is airways, this is railway. This is just to differentiate. Earlier they both were like this. So I know that this airway would revolve around 0 to n. So I just added n so that they both, now I can differentiate. Now I can just subtract minus n, I can get the index. So indexing is also preserved. Still they are different from each other. Okay? Then we both have the same thing in the graph. Now I would insert the value of x for int I is less than n and I plus plus, and then we would say adj of I dot push back I plus n. So I was what? Every ith value is airways and this value is railway. So airway to railway. How much time would be taken for this? X. Sorry. Yep. So how much time would be taken for this? That is X. Do we have X? Yes, X is in lowercase. And then the vice versa. From railway to airways also it would be X only. So I would copy this thing, and here I would just write I plus n, like the vice versa. If I can go from my, like, to reach my girlfriend's house, I need 10 rupees. So my girlfriend would also require 10 rupees to come to my house, no? Same ways, my house to my girlfriend's house, from my girlfriend's house to my house, and it would be the same thing. Then we would initialize with a very high value, because we want the minimum value to get to catch the minimum value. We would initialize with it with a very high value. So long answer is equal to 1e18. 1e18. So I'm writing 19. Okay, and then we would start the Dijkstra. Okay, answer is equals to that. We would start from railways. Okay, D. Okay, Dijkstra. So answer would be that first we would start from railways. Okay, Dijkstra of SRC, comma destination, comma n. Okay, comma n using the adjacency matrix. And then answer would be min of, again the same thing. We would just copy the same thing. First we are starting off from railways. Okay, from airways. Okay, ith value is airways. This time we need to add source plus n so that we can start from railways. Okay, this is done. Now minimum would be the answer. So even at the end we are not able to get the answer, that the answer is still the same thing, then we would say a path is not possible, else we would return the value of answer. And the extra is the same thing, like using the priority queue. Okay, I made a mistake somewhere. Let me find the mistake now. This is the most crucial step. I comma 0. Do I have any comments? Sir, so okay, zoom your editor, zoomed up. Sir, so node I and IS plus 1 belong to the same city? Yes, they both belong to the same city. I denotes railway and I plus N denotes, so sorry, ith node denotes airway and I plus nth denotes railway. Okay, wrote it and gave it to you. Okay, now, now let me just find the error that I'm making. Okay, this one would be M2. Found the error at this point. Any more further errors I have? RL. I didn't write much. Okay, we would start from source and destination with n at the adjacency list, source and the destination. Now let's just compile and run. I hope I won't get any errors. Okay. So while I was copying the first loop, I forgot to make it from M1 to M2. Okay, this is done. So I would just pass on this code to you, because I found out that in the last stream some people were asking me the code. So I can't paste the whole code. Neither I can paste a link in the code, like link in the comment. This is not allowed by YouTube. That is why even though I was seeing that comment, I wasn't able to reply. So when you are asking me for links or something in the chat, links or something in the comment section, kindly connect with me on LinkedIn. I would be more than happy to do it. Please don't ask links or those things in the comment section, because I'm not I'm reading it, I'm seeing it, still I'm not able to do it, and that makes me feel sad. Okay. In the extra, they are returning minimum of distance. Yes, that is just returning. There should be four cases: A to A to R. No, Dijkstra is in that way. The Dijkstra, see, so Dijkstra, as we have the whole graph, Dijkstra would, like, you can handle four cases. But still, I would just explain you why the handling of four cases is not required. Why? Because Dijkstra would would take the optimal on its own hand. Okay, Dijkstra would tell us that yes, this is optimal. Like stopping on the airline is optimal, or stopping on the railway is optimal. Which is optimal, Dijkstra would decide. But if we start off, like let's say, I start off from an airline, but Dijkstra wishes me to go from railway. So I would have X more. That is why we are just seeing from both the perspective. That railway se start karo ya nahi karo. Okay. So I would be waiting for the last 1 minute. If I don't receive any doubts, I would turn off this session. Okay. They have implemented extra 4 returns. Yep. I have implemented it. See, it would return this. See, it is handled in this fashion. Yep. Line number 31. Because see, Dijkstra is an algorithm which is a single source shortest path. From that point, we can get the shortest path to every other point. So we can just take the minimum of both, and we don't need to handle four cases. Two cases are saved at our point. Okay. Okay. By the way, you can use multi-source Dijkstra also, but doing Dijkstra two times is better than using multi-source Dijkstra. That is why it is not as visible, but you can use multi-source Dijkstra. So in the last weekend, it was a little bit difficult. Like many people had few problems that I'm not able to write, or like the screen is not visible. I was having a lot of issues back at that point. But this time, due to God's grace, the whole editor or the writing pad went smooth, and eventually I would just continue using my iPad, because the annotations or other stuffs are very much simpler and easy to write. So that's it for today. Enjoy your weekend for the last 2 hours. Thank you, everyone. So if you're watching the stream on so if you're watching the stream on the recorded version, kindly like and comment the video so that the reach of this video could be increased and this hard work could be justified. Thank you, everyone.